So now you've got the argument of why we think it's happening, how it's caused. The next thing is to look at what are the challenges related to climate change. So why do we even care if this is happening? So just to go in a little more detail about what the changes mean. First, there's an increase in the mean, so an increase in the average temperature that's happening. And as you can see in this chart, that means more hot weather and more record hot weather. There's also an increase in variance. So this means that the variety of different types of weather we can have is larger. So again, that leads to more hot weather, more record hot weather, but also more cold weather and more record cold weather, just an increase in variance. So when you put those two together and look at what's happening now, we're getting an increase in the mean temperature and also an increase in the variance. And so actually, we won't see that much change in cold weather, and kind of record cold weather, but we will see much more hot weather and significantly more record hot weather. So one of the first things that you're probably thinking of, and you hear quite often about climate change, is the effect on severe storms. So in the quiz that we did first, you saw that the increased warming leads to increased water vapor in the air and increased precipitation. So that's part of what drives larger storms. And also in general, with that change in the mean, change in the variance, these storms become more likely to occur. So a lot of times you hear the debate of people say, oh, Katrina was caused by global warming, or these droughts are caused by global warming. And the difficulty with saying that is it's hard to pinpoint any particular thing happened because of global warming, any particular severe storm. What they can say is the likelihood that a storm of that magnitude would occur was more likely because of the warming. So it's a little bit less direct. So some of the other direct effects that this is going to have on people and on people's lives and livelihoods. The first one I want to talk about is precipitation and drought. So in particular, in the southwestern United States, one of the things they're already seeing with increased temperatures is increased earlier snow melt. So the snow on the top of the mountains melts, that puts fresh water into the rivers, used for irrigation, it's used for towns just using any kind of water consumption. But that snow is now melting earlier in the year. So one of the biggest problems with that is that now you get more water in kind of the spring and the early summer, and less water in the late summer when you usually have the hottest temperatures. So unless we have really good mechanisms to capture that water, you have issues with severe drought and with water shortages. Going along with that early snow melt is an increase in wildfires. So you can imagine you have hotter conditions, you have drier conditions, especially in the end of the summer, and that leads to more forest fires. So that's another change that has been documented already, an increase. So just to quote the numbers for you, between 1987 to 2003, there was nearly 4 times the average number of forest fires than there were from 1970 to 1986. And also the total area burned by these fires was more than 6.5 times the previous level. So the forest fire increase is pretty significant. And I have a couple little case studies here to show specific effects that have happened that are climate related and affected the environment. So in 2002 to 2003, about 40 to 80% of these Pinion pine trees died in the Southwest. There was a drought, and the drought was actually really similar to droughts they'd had in the past as far as the amount of precipitation. But the temperatures were also very high in this case. And that created stress on the trees, and they weren't able to produce sap. And when they don't produce enough sap, then they're susceptible to insect infestations. And so what happened was there was a pine beetle, bark beetle, that came during this period, which generally does. But because the trees were so water stressed, so heat stressed, they weren't able to fight off that attack. And so there was a huge impact in this particular year. Another example, also to do with pine trees, is the case of needle blight in British Columbia in Canada. So this is an area where they've had issues with needle blight in the past, but generally it doesn't cover huge areas and it doesn't really cause the death of a lot of trees. In this case, 92% of the trees in this British Columbia area had needle blight, and about almost 10% of them were so badly hit that they probably wouldn't recover. So that's really unprecedented numbers for that particular area. And the reason that they found that had happened is that they had had warmer and wetter summers. So this needle blight is essentially a fungus. You can imagine if you had warm is not such a problem, but if you have less precipitation, they used to have relatively dry summers, then the fungus can't survive. And so it never could really thrive and cause a big issue for the trees. But with climate change, you have hotter weather, but you also have increased precipitation. And this area is a place where it is getting more rainfall, and that allowed the fungus to really thrive and is now kind of killing off these forests. Okay, so moving on to ice. One of the things you hear a lot about and that we are able to measure really pretty well is the decrease in Arctic sea ice. So there was a lot of news in 2007 when we hit that record low that was quite significantly lower than anything we had in the past. And we care about sea ice mostly because it adds fresh water to the ocean. So sea ice is not really a problem for sea level rise, right? Because ice that's already in the water, when it melts, doesn't cause any rise. I also want to point out this Antarctic sea ice. So Antarctic sea ice has actually risen by about 1% per year over this period. And you really don't hear about that very often. And the reason that you don't hear about it is because, first you can see, the change is a lot less clear. It's also, the 1% change is much smaller than the changes we're seeing in the Arctic. So it's really kind of overpowered by the sea ice loss in that area. And also in the Antarctic, every year the sea ice melts almost completely and then comes completely black back. So small changes in the amount of sea ice really don't affect the system that much. Whereas in the Arctic, we never used to have the sea ice completely disappear. That would be completely unprecedented. So really large decreases in the amount of sea ice in the Arctic are a much bigger change for the environmental system. So as I mentioned, the main issue with losing that ice is you add fresh water to the ocean. So I have on here a picture of the ocean circulation. It's called the thermohaline circulation. And it's called that because the way water moves around the Earth basically depends on its density. And the density of water is just based on its temperature and its salinity, so how much salt is in the water. And what happens right now is that warm water goes up to the Arctic and gets cooled and then sinks and goes back south. So the concern is that if there was a lot of ice melt or if there were large ice sheets that came off in the Arctic, you could add a whole lot of fresh water to that. The fresh water is more buoyant than salt water, and so instead of the water sinking in the Arctic, it would stop sinking and you would shut down that circulation. Scientists also actually think that has happened in the past. This is about 12,000 years ago-ish. And they call it the Younger Dryas period. It basically caused extreme cooling in Greenland and North America. So there is some precedence for the idea that it could happen. Scientists don't really know exactly at what point would be the tipping point there. And I put up this picture here because the movie The Day After Tomorrow, how many people have seen that? Okay, so that was a very inaccurate representation of this effect. But exciting. Another concern, somewhat related to ice, is the loss of permafrost. So as you can see, all the purple on here is continuous permafrost. That's ice in the soil that stays frozen for at least 2 years. And one of the biggest concerns with the permafrost there melting is that a lot of that area also holds significant stores of methane. And methane is a very potent greenhouse gas. So if you see melting of permafrost, that could really be a large feedback to climate change and to warming. So we talked about sea ice, we talked about permafrost. This is land ice. So land ice, we're also seeing a pretty significant trend of decrease over time. The two areas we're probably the most concerned with are Antarctica and Greenland. because those are areas where there are very large ice sheets that can go into the oceans, and then ice that is on the land, as opposed to sea ice, does cause sea level rise. So that's the kind of biggest concern when we see the ice decreasing here. These graphs are showing the actual measured sea level rise that's been occurring so far. The thing I want to really point out in these graphs is the rate of sea level rise. So we'll talk a little bit about what the magnitude means and what effect that has on the Earth. But one of the really important things to keep in mind is how quickly it's happening. So sea level rise that happens very, very slowly is relatively easy to adapt to, or easier at least. Whereas if sea level rise starts to happen much more quickly, it's almost impossible for whole cities or whole areas to adapt quickly enough.
What do they have to explain that little dip that we're currently in?
I think it's just natural variation. So I don't think it's large enough to be of concern, but or to change the overall.
Like a 16-year trend, but it's interesting.
Yeah. So these are maps that are just showing the effect of a sea level rise in different areas. So I put Florida on here. Is anyone from Florida? There you go. Are you? I think Professor Holden showed similar slides earlier. So there's a pretty significant part of Florida, all of Miami, also New Orleans, that's completely underwater if we get to 6 meter sea level rise. 6 meter sea level rise would really only happen if we had significant losses of the Greenland ice sheets and the Antarctic ice sheets. So that's hopefully not going to happen, and in any case, the ways off. But these 1 meter rises that you see on the top can happen even just from expansion of the ocean. So as the water heats up, it takes up more room, and that increases the surface height. So those are some of the effects. You also see really large effects in Southeast Asia, so particularly in China and Bangladesh. There's a lot of population, a lot of people that live in really low-lying areas. So there's the changes they would see. Another concern, on those graphs, it's showing would you actually be underwater. But that's not really your only concern with sea level rise. Even if you're not literally going to be underwater, there are a lot of problems that you can run into. So, for example, storm surges reach farther, are bigger, and cause more problems. What's shown in these pictures is increased erosion. So clearly these people are still above water, but that's probably not cheering them up much. Since the water is higher, it's digging more in the land on the coast. So that also can affect habitation. Ocean acidification, I won't go into in much depth because Professor Holtman covered this in an earlier class. But I just want to mention it because that is one of the things tied into climate change. So as we're seeing carbon dioxide increases in the atmosphere, some of that carbon dioxide is taken up by the oceans. It causes acidification, so oceans are actually basic, not acidic, but they're becoming less basic. So, and what happens is that then the little animals in the sea, the little microorganisms that create calcium carbonate shells, are no longer able to do that, or they have a harder time doing that, because the shells, just the molecules can't exist in that level of acidity.